What if we nuked Mars? It begins not with a bang on Earth, but with a flash of impossible brightness over the rust-red sands of Mars. At 0700 UTC, three synchronized nuclear warheads detonate above the Martian equator, the result of a controversial joint operation between two rogue spacefaring nations, claiming to be terraforming pioneers. Their goal? To kickstart a warmer Martian atmosphere, releasing CO2 from the polar ice caps and possibly awakening a sleeping planet. But instead, they woke something else. The Martian sky lights up with auroras as high-energy particles scatter through the thin atmosphere. Telescopes on Earth catch the surreal glow even before deep space satellites register the shockwaves. Within hours, the explosion becomes the most watched event in human history. Newsrooms scramble, conspiracy forums ignite, and governments issue vague statements about off-world testing protocols. But beneath the viral headlines lies a far darker truth. The surface of Mars isn't just dust and ice. It's chemically reactive, radiation-baked, and volatile. And when bombarded with the immense energy of nuclear fusion, that cocktail becomes unpredictable. Let's rewind for a second. The idea of nuking Mars isn't new. In 2015, Elon Musk casually suggested it during an interview, saying it could be used to terraform the planet. The concept was simple in theory. Drop nukes over the poles to vaporize CO2 ice, thickening the atmosphere and warming the planet. But most scientists pushed back, citing both the lack of nuclear yield required and the ethical concerns of irradiating an entire planet. But now, someone has done it, and the consequences are spiraling out of control. First came the Martian dust, superheated, irradiated, and flung into the upper atmosphere at velocities never before observed. Then came the strange electromagnetic pulses that briefly disrupted satellite signals across Mars' orbit. And then, a faint but measurable shift in Mars's orbital wobble, as if the planet itself flinched. No one was ready for what would happen next. Not Earth, not the astronauts stationed on the Martian moon Phobos, and certainly not the delicate balance of the solar system itself. Because this wasn't just a shockwave on a dead world. This was the beginning of a chain reaction that would reach across 140 million miles of space and hit us where it hurts. What actually happens to a planet when you nuke it, and how does the solar system respond? Let's dive into the science behind the explosion. To understand what we just did to Mars, we need to zoom in, deep into the heart of that explosion and what it triggered. Nuclear weapons, whether fission or fusion, release energy at an almost unimaginable scale. A single warhead can vaporize a city. 3 strategically placed bombs above Mars's equator deliver a blast equivalent to several million tons of TNT. But the Martian surface isn't just passive terrain, it's a geochemical minefield. The crust is loaded with perchlorates, highly reactive chlorine-based compounds that are stable in Mars's frigid climate, but become dangerously volatile when heated. When the nukes detonated, they didn't just vaporize the surface ice. They cracked open the chemical vault. Perchlorates began reacting with atmospheric trace gases and the heat from the blast, forming clouds of corrosive, radioactive aerosols. That red dust we saw spiraling into the sky? It's not just dirt. It's a toxic cocktail of iron oxides, ionized particles, and vaporized chemicals now mingling with solar radiation in Mars's thin, unshielded atmosphere. On Earth, our magnetic field protects us from solar wind. Mars, stripped of its magnetic shield billions of years ago, offers no such protection. The result? A nuclear-excited ionospheric storm. High-energy particles collided with the solar wind in chaotic waves, creating an unpredictable electromagnetic pulse. It spread like ripples in a pond, disrupting communications across Mars's orbit and even reaching Earth's deep space listening posts. But there's more. Nukes generate shockwaves, not just in air, but in geology. On Earth, underground nuclear tests have been known to alter groundwater flow and even trigger minor seismic events. On Mars, the blast penetrated deeper. With no plate tectonics or liquid core to absorb the shock, the energy echoed through the crust like a bell struck in a vacuum. Seismic sensors on Phobos picked up vibrations that didn't match any known Martian quake. Something shifted. Meanwhile, a plume of radioactive dust began to drift into space, riding the solar wind toward the inner solar system. Earth's satellites detected the incoming particles, faint but traceable. The concern wasn't just contamination, it was proof. Detonating nukes on another planet had effects beyond that planet. We hadn't just nuked Mars, we had shouted into the void, and the solar system had started to whisper back. Global panic, military confusion, and the race to understand what just happened. How do humans respond to a crisis they triggered on another planet? It started with a brief interruption in satellite data, a few seconds of static from NASA's Deep Space Network. Then came the reports from the European Space Agency, an unexplained burst of radiation consistent with nuclear detonation, originating from Mars. Within minutes, Twitter lit up like a solar flare. Red Planet Crisis was trending globally. At first, the public didn't know what to believe. Was it a test? A terrorist attack? A cosmic accident? The lack of an official response only fueled the panic. Back-channel intelligence began flowing between space agencies. NORAD raised its alert status. The United Nations Space Committee called an emergency session for the first time in its history. Within hours, President Clark appeared on live television, her face grim beneath the American flag. Preliminary evidence confirms that nuclear detonations have occurred on the surface of Mars, she said. We do not yet know the full consequences, but rest assured, every effort is being made to assess the situation. In short, no one knew what the hell was going on. The culprits were eventually revealed, a rogue coalition of 2 nation-states and a privately funded techno-nationalist group called Helios Forge. They claimed they were accelerating terraformation for the benefit of humanity. Their press release included buzzwords like planetary engineering and off-world sovereignty, but the world wasn't buying it. Military analysts feared the worst. Had the detonation been a cover for something else? Biological testing? Alien contact gone wrong? Theories spiraled. Meanwhile, Mars' orbit began showing signs of strange activity, plumes, radiation spikes, and irregular heat signatures. Some thought the planet might be reacting in ways no one expected. Meanwhile, astronauts on the Martian moon Phobos, still stationed at the small research base named Outpost Hawking, reported feeling mild tremors and radiation anomalies. Earth ordered immediate evacuation, but it would take weeks for a rescue mission to arrive. The crew, isolated 140 million miles from home, became both eyewitnesses and lab rats for the unfolding Martian mystery. Back on Earth, public trust in space governance eroded fast. Protests erupted in front of space agency headquarters. Activist groups demanded a planetary moratorium on all off-world nuclear activity. News outlets ran apocalyptic headlines, "Have we ruined Mars forever?" and "Fallout from the final frontier." And then came the misunderstanding that nearly started a war. China's Mars observation satellite experienced critical failure during the radiation surge. Beijing believed it was sabotaged. They blamed the United States. Tensions soared. Accusations flew. For 48 terrifying hours, Earth itself teetered on the edge of conflict over something that happened millions of miles away. In the end, cooler heads prevailed. A temporary treaty, the Mars Detonation Accord, was drafted, banning all future nuclear use beyond Earth's orbit. But it was already too late. The bomb had been dropped, the chain reaction had begun. And Mars wasn't done responding. What happens to Mars's environment, and Earth's, in the wake of this detonation? Prepare for toxic skies, weather gone rogue, and planetary dominoes. 1 week after the detonation, Mars looked different. From orbit, the change was obvious. The southern polar cap, once gleaming white, now shimmered with a strange coppery hue. The ice hadn't just melted, it had boiled. The 3 nuclear blasts detonated high in the atmosphere, superheated the surrounding air, and kicked off an artificial greenhouse effect. Exactly what the rogue actors had hoped for. But what they hadn't counted on was the chaos that followed. Mars's thin atmosphere, less than 1% the pressure of Earth's, isn't good at holding heat, but introduce millions of tons of CO2 from sublimated polar ice and irradiated regolith, and you get instability. Temperature gradients formed between hot zones near the equator and cold pockets at the poles. And on a planet where even a slight breeze can stir up global dust storms, this imbalance was like lighting a match in a room full of sawdust. Within days, a storm the size of North America erupted, spiraling across the equator. Dust devils reached miles into the sky, carrying radioactive particles with them. The fine iron-rich powder, already known for being electrostatically charged, became an airborne poison, blanketing the planet and blotting out sunlight. This was no ordinary Martian storm. This one shimmered. The dust, irradiated by the nuclear blasts and energized by solar wind, began emitting low-level luminescence. Ghostly green glows danced on the edge of the horizon. For the astronauts stranded on Phobos, the sight was beautiful and terrifying. But the impact wasn't limited to Mars. Dust particles began escaping the Martian gravity well, pulled into space by solar radiation pressure. Over the next several weeks, Earth's instruments detected microparticles drifting into the inner solar system. These fragments, though tiny, posed serious concerns. Could they carry radioactive contaminants? Could they damage spacecraft electronics? More urgently, how many were already on a trajectory toward Earth? On Earth, meanwhile, scientists drew grim comparisons. The Martian atmospheric reaction resembled Earth's own past extinction-level events. When the Chicxulub asteroid struck 66 million years ago, it vaporized rock, blasted it into the stratosphere, and plunged the world into a years-long winter. The nuclear detonation on Mars was nowhere near that scale, but the mechanics were eerily similar. We'd triggered a planetary-scale climate event. Mars, once stable in its barrenness, had entered a volatile new era. Winds accelerated, radiation levels spiked. Atmospheric pressure rose just enough to alter the rate of chemical reactions on the surface. There was even speculation that subsurface permafrost could thaw, potentially releasing methane, another potent greenhouse gas. Back on Earth, news anchors compared it to a biblical plague. Headlines read, "We tried to warm Mars and set it on fire." And amid all this, a strange signal was detected beneath the Martian crust. Some thought it was natural, others weren't so sure. As the environment turns hostile, humanity scrambles to survive its own mistake. Food shortages, tech failures, and psychological breakdowns emerge. Who adapts, and who collapses? By week 3, the Mars crisis wasn't just an off-world story. It had crossed the cosmic threshold into Earth's reality. In the minds of ordinary people, Mars was no longer a distant curiosity. It had become a symbol of humanity's hubris, and its consequences were arriving faster than expected. First came the satellite failures. The radioactive dust ejected into interplanetary space wasn't just a threat in theory. Microparticles traveling at thousands of miles per hour began damaging sensitive sensors and optics aboard Earth-orbiting satellites. Communications relays flickered, GPS systems briefly glitched. For the first time, humanity experienced the consequences of an interplanetary chain reaction, space debris with a Martian passport. Then came the food panic. It started small, a few isolated climate anomalies likely linked to solar interference. But people were already on edge. Speculative doomsday influencers pushed a terrifying narrative that Mars's dust storm might alter solar radiation levels reaching Earth. Some claimed it would trigger a mini ice age. Supermarket shelves began emptying. Food futures surged. Governments scrambled to reassure the public. But the damage was done. In truth, the risk of global cooling was minimal. But psychological damage? That was real, and spreading fast. Mental health hotlines reported a 60% spike in calls related to eco-anxiety and space disaster fears. Online, Mars Doom Challenge trended. People filming themselves sealing windows with foil or wearing makeshift radiation suits. TikTok therapists offered tips on coping with interplanetary dread. It would have been funny if it weren't so sad. Meanwhile, the Phobos crew's situation had worsened. Their radiation shielding, designed for brief solar flares, not weeks of exposure to radioactive dust, began to deteriorate. One astronaut developed signs of acute radiation sickness. Earth's rescue mission wouldn't arrive for at least 18 more days. Desperate for solutions, governments and private companies pivoted hard. SpaceX and Blue Origin repurposed existing launch assets for Mars-bound cargo missions, focusing on emergency resupply and satellite repairs. China proposed an orbital debris interceptor to blast away incoming Martian dust, though skeptics argued it might do more harm than good. On Earth, the private sector began pitching survival infrastructure, underground living modules, indoor agriculture kits, even AI-powered greenhouse systems advertised as Martian-tested. For the first time, terraforming tools meant for Mars were being advertised as Earth survival gear. The irony was lost on no one. But perhaps the most troubling sign of all? People stopped trusting each other. Nations that once cooperated on space exploration began hoarding technology, preparing for a future they feared was already broken. The dream of a shared cosmic destiny was fading, replaced by survivalist realism, and yet, amid the panic, some scientists started thinking bigger. If we could destroy a planet's stability, could we also learn to stabilize it? Humanity looks to adapt through radical technologies, genetic tweaks, and new political systems. Could the Martian disaster become the blueprint for surviving ourselves? By month 2, the crisis had shifted from shock to strategy. The realization was settling in. We might have nudged Mars into a new climate phase, and in doing so, opened a mirror to our own fragile existence. Earth hadn't yet suffered physical catastrophe, but the psychological and technological aftershocks were being felt everywhere. The message was clear: we were vulnerable. And vulnerability, historically, breeds innovation, or extinction. So humanity did what it does best. We adapted. Underground bunkers, once fringe survivalist fantasy, became a serious topic in national defense briefings. Subsurface living wasn't just a doomsday option, it was insurance. From Wyoming to Siberia, engineers began designing next-gen habitat pods modeled partly on concepts meant for Mars colonization. Closed-loop hydroponics, algae-based oxygen regeneration, and radiation-shielded architecture. If nuking Mars had proven anything, it was that Earth's atmosphere wasn't guaranteed, and underground might be our fallback plan. Meanwhile, geneticists stepped into the spotlight. For years, the idea of genetically modifying humans for space was taboo, science fiction at best, unethical at worst. But now? It was a headline on CNN. Should we genetically adapt for the next planetary crisis? CRISPR researchers proposed modifications for radiation resistance, bone density retention, and even low oxygen environments. It was controversial, but the Overton window had shifted. Economic systems, too, began to change. Traditional industries like aviation and oil took a hit as international travel waned and environmental concerns surged. In their place rose a new industrial complex: planetary defense and exo-environmental stability. Corporations with names like TerraShield and Orbital Dusk offered space weather insurance and contaminant forecasting systems. Governments poured billions into planetary contingency programs. Mars had become both a warning and a business opportunity. Politically, everything was in flux. The UN passed the Planetary Non-Aggression Treaty, forbidding nuclear detonations on any celestial body, but enforcement was unclear. A new alliance emerged, the Coalition for Exoethics, uniting environmentalists, scientists, and futurists under a single creed: do no harm beyond Earth. But even that wasn't enough. Some thinkers argued the opposite. If we had already broken Mars, we should finish the job, intentionally terraform it, not abandon it. Turn failure into function. Make Mars habitable, not just because we can, but because we must. Earth's limits had become clearer than ever, and space was no longer an abstract dream. It was Plan B. So plans emerged for orbital habitats, O'Neill cylinders, Martian greenhouses, even lunar way stations. Technology that once felt centuries away suddenly had funding, urgency, and purpose. Power, too, was shifting. The old space powers, NASA, Roscosmos, ESA, were now part of a crowded field. Tech giants, micronations, and AI-governed consortiums entered the space race with bold declarations and bigger risks. Authority fragmented. The question wasn't who governed space anymore. It was whether space could be governed at all. And yet, in the middle of this frenzied adaptation, Earth watched as Mars began to change on its own. Dust storms waned, methane readings spiked, infrared scanners detected rising surface temperatures in isolated pockets. Had the nukes actually triggered terraforming? Or something worse? A turning point. Is Mars beginning to recover or transform into something we can't control? And what secret lies beneath the surface, waiting to emerge? It began as a whisper in the data, an anomaly in the temperature logs from Mars's equatorial region. A team of exoplanet climatologists in Argentina noticed it first. They were reviewing surface heat patterns from satellites still operational above Mars when they saw it. A steady, localized temperature increase in a narrow rift valley near the ancient region of Valles Marineris. But it wasn't just warming. It was pulsing, like a heartbeat. At first, it was dismissed as a sensor glitch. But then the Chinese rover Shenlong 7, which had survived the detonation by sheer chance, recorded something even stranger. A faint, rhythmic vibration beneath the crust. Not seismic, not tectonic. Something else. Something timed. And then the methane spike. Methane on Mars had always been a scientific mystery. In small amounts, it suggested geological activity, or even microbial life. But now? Concentrations were rising by an order of magnitude in areas where the nukes had struck. And they weren't dissipating. Theories bloomed like wildfire. Had the explosion triggered dormant geological processes? Had it cracked open ancient methane reservoirs frozen for millions of years? Or had it awakened something biological? The global scientific community split down the middle. Some argued it was just natural chemistry, a consequence of heat interacting with subsurface ice and minerals. Others began whispering the unthinkable, that microbial life, long theorized to exist in the Martian subsurface, had been kick-started by the nukes. And if that life had adapted to the irradiated conditions of Mars, what else could it become? Back on Phobos, the stranded astronauts finally received resupply, but not before they too witnessed something unsettling. During a low-orbit pass, their sensors picked up anomalous readings in the infrared band. Small, moving heat signatures near the detonation sites. They were dismissed as thermal ghosts, leftover energy trapped in regolith pockets. But two crew members swore they saw movement, patterns that didn't match wind behavior or dust flow. One even described it as, like something crawling beneath the surface. NASA scrubbed the footage before release. And then came the signal. It wasn't a message, at least not in the way we understand communication. It was a narrowband electromagnetic pulse emanating from deep beneath the Martian crust. Not regular, not random, repeating. Some speculated it was natural resonance. Others thought it was Martian magnetic harmonics, a fluke of geology. But a few independent labs, running the signal through spectral analysis, noted a terrifying possibility. The pulse matched no known natural frequency. It had structure. It had intent. What had we done? Had the nuclear detonations merely changed the environment, or had they cracked open an ancient biosphere? Could Mars have once held life that had gone dormant for eons beneath the irradiated crust, frozen in time? And had we, in our arrogance, woken it up? The world paused. Terraforming had seemed like a noble dream, but now it looked like an interplanetary intrusion. And the consequences, biological, cosmic, maybe even existential, were just beginning. Rebuilding begins, on Earth and Mars alike. But the shadow of what we've unleashed hangs over everything. Can humanity fix what it's broken, or have we gone too far? It took 3 months for Earth to breathe again. The immediate fallout from the Martian nuclear detonation had subsided. The dust in the solar wind was thinning, Satellite systems, after dozens of orbital repairs and retrofits, began to stabilize. The panic was ebbing. But in its place came a quieter, heavier feeling. Grief. Grief for what could have been. Grief for what we might have awakened. On Earth, the rebuilding process was less about shattered cities and more about repairing broken trust between nations, between citizens, between humans and the cosmos. The UN formed the Council for Interplanetary Ethics, tasked with setting new boundaries for space activity. It was mostly symbolic, but it gave people hope that someone, somewhere, was trying to prevent another cosmic misstep. Technologically, the crisis had catalyzed a renaissance. Engineers accelerated the development of next-generation planetary sensors, autonomous habitat builders, and biological contamination protocols. What had been niche research became mainstream priorities. The phrase planetary containment entered every scientific lexicon. Education shifted too. Schools taught space science not as distant aspiration, but as vital planetary awareness. Children were raised knowing what a biosignature was, how nuclear isotopes affect soil chemistry, and why Martian methane mattered. We had cracked the solar system's shell, and it was too late to retreat. On Mars, strange changes continued. The equatorial regions, once cold, dry plateaus, now showed intermittent signs of surface frost melting and evaporation. CO2 levels in the atmosphere had increased marginally, just enough to nudge local pressure upward. NASA and ESA probes reported water-like vapor trails in sheltered craters. Could this be the first signs of terraforming success, or something more dangerous? Mission planners faced a dilemma: return to Mars and study the aftermath firsthand, or observe from afar and avoid potential contamination. The argument fractured the scientific community. Some believed we had a moral obligation to understand what we'd done. Others warned that a second intrusion could tip an unstable system and maybe unleash something not meant to be touched again. But someone had to go. A new mission, dubbed Project Lazarus, was announced, a joint operation between 5 space agencies and 2 private companies. Its goal? Land on Mars within 2 years, establish a sterilized research zone, and monitor biological signatures from beneath the crust. But this time, the mission wasn't armed with drills and rovers. It was armed with quarantine protocols, self-destructing labs, and biocontainment drones. Earth had grown cautious, yet amid the caution, signs of resilience bloomed. Forests began to be planted en masse to counteract lingering ecological fears. Indoor farming technologies inspired by Mars greenhouse concepts were now powering food security programs in Africa and Southeast Asia. Water purification systems designed for Mars helped clean toxic rivers on Earth. We had nuked another planet and learned how to heal our own. Still, one question echoed through the halls of every laboratory, newsroom, and government chamber. What if something on Mars wakes up, and it's not friendly? We explore the legacy of the detonation. Has it altered humanity's path forever? Is this the moment we truly became an interplanetary species, or just one more species that poked too far into the dark? It's been 5 years since the detonation. In the history books, the event is now called the Red Scar, a name both poetic and haunting. School children learn about it alongside the moon landing, Chernobyl, and the extinction of the dodo. It has become one of humanity's definitive moments, the day we proved that even the silence of another planet wasn't safe from us. But what legacy does that leave? Some believe it marked the beginning of the interplanetary age. After all, the crisis spurred rapid advancements in space technology, deepened global cooperation, and fundamentally changed how we view other worlds. Not as abstract places on a star map, but as interconnected nodes in a shared cosmic system. Others say it was a moment of cosmic trespass. The detonation awakened something, if not literally, then morally. It showed that we were willing to manipulate, weaponize, and experiment on a world without truly understanding it. And maybe, just maybe, Mars responded in kind. Project Lazarus made contact with the Martian surface 2 years after the incident. Its results remain partially classified, but leaked reports suggest something incredible. Microbial structures found just beneath the regolith near the blast site. Alive? Possibly. Native? Almost certainly. Ancient? Beyond question. One memo described them as genetically unlike any known terrestrial lineage, but displaying signs of biochemical activity when exposed to liquid water. In other words, life. Or at least, the spark of it. Had we triggered evolution, reawakened something dormant, or simply exposed a process that had been slowly building for millennia? No one knows for sure, but one thing is clear: humanity would never again look at Mars, or itself, the same way. Culturally, the red scar became a symbol of reflection. In films, it was the backdrop for philosophical sci-fi dramas. In music, it inspired entire genres of melancholic space opera. On social media, it lived on as a cautionary meme: don't nuke the neighbors. But something deeper shifted too. For the first time, a majority of Earth's population supported strict space governance, environmental stewardship, and interspecies ethics, even hypothetical ones. The idea of preserving alien ecosystems, even lifeless ones, took root. Space became sacred ground. Meanwhile, the private sector leaned into exploration with a new kind of reverence. Colonization gave way to partnership. Terraforming became biocompatibility. Mars wasn't something to be conquered, it was something to be understood. And on Earth, the fear of extinction had rekindled a desire for continuity. Long-term space settlements were no longer framed as prestige projects. They were insurance. Arc ships were being tested in low Earth orbit. Cryogenic preservation and AI-assisted survival became standard features of off-world missions. Mars had become our teacher, a mirror, a warning, and maybe our next frontier. But beneath it all, the question remains: did we set the first spark of a living Mars? Or the first stage of something we can't take back? Where do we go from here? An optimistic, pessimistic, and realistic look at humanity's future among the stars, and what the Martian detonation ultimately teaches us about ourselves. And so, here we are. 5 years after we detonated nuclear bombs on a silent, frozen planet, the world has changed. Not through catastrophe, but through reckoning. Mars didn't explode. It didn't rain death from the skies. There were no alien invasions, no red dust apocalypse. But in many ways, the event shook us more than any asteroid ever could. It forced us to look outward and inward. The Martian experiment became a planetary mirror, reflecting our deepest ambitions and darkest impulses. We thought we were building a second Earth. Instead, we rediscovered the fragility of the first. We believed we were starting a new chapter in space exploration. But maybe we were reading the wrong book. Still, humans adapt. Always have. In the years that followed, we learned to tread lighter. Space became less of a frontier and more of a responsibility. Every probe, every lander, every colony plan was shaped by one looming question: should we? Not just can we terraform, conquer, or extract, but should we? It was a moral pivot as significant as any scientific one. Optimists say we've grown. Mars is now home to a network of observational outposts designed to study, not terraform, its evolving environment. The atmospheric changes triggered by the nuclear blasts have stabilized somewhat, and strangely, have even made small parts of the surface briefly habitable, if only for microbes. Earth, too, has changed. Environmental policy took a sharp turn. Geoengineering plans once reserved for climate emergencies were tested, cautiously, with lessons learned from Mars. We started solving Earth's problems with the humility we should have shown the red planet. But pessimists argue the opposite. They warn that the detonation proved humanity's tendency to act first and ask questions later. They fear that next time, on Europa, Titan, or some exoplanet light years away, we won't stop at 3 bombs. That the red scar will be just the first in a long string of cosmic mistakes. And yet, realists stand somewhere in between. They say we've passed a threshold. We're not just Earthlings anymore. We're an interplanetary species, by action, if not by right. What matters now isn't whether we leave Earth, it's how we choose to arrive wherever we go next. Are we guests, gardeners, gods, or something in between? Maybe the detonation was our cosmic adolescence, the moment we realized we could break things far beyond our own world. The real test is what we do with that knowledge. Will we destroy, or will we learn to nurture? And perhaps that's the legacy of Mars, not a warning, not a triumph, but a lesson that the universe doesn't belong to us. But we do belong to it, and like all things that belong to something greater, we have a responsibility to care, to wonder, and above all, to listen before we speak in nuclear fire. Nuking Mars didn't end the world, but it changed it forever. From ethics to engineering, from panic to progress, this hypothetical teaches us one thing. The real frontier isn't Mars, it's responsibility. So what do you think? Should we ever terraform a planet? Or should some worlds remain untouched? Comment below. We want to hear your thoughts. And if you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and join us for the next What If?